This is going to be the first of 2 or 3 videos I plan to produce for normal probability distribution. Normal probability distribution is a big topic, and I will not unload too many ideas in one video. We shall do it in small chunks of information. Normal probability distribution. So there are 2 things to keep in mind when we speak about normal probability distribution. It is the probability distribution of a continuous random variable, real valued variable. When you say real valued variable, it is a variable that will take on values that is a real number. Its probability histogram is a continuous curve in the shape of a bell. Okay, so let us pay attention to the first thing to remember about normal probability distribution. So it is a probability distribution of a continuous random variable. So what is a continuous random variable? Well, one way to see the characteristics of a continuous random variable is to compare it with something that is a discrete random variable. My analogy for a discrete random variable would be the set of integers or a subset of integers. It's not a perfect analogy, but I will use it anyway because it is showing to us the essential characteristics of a discrete random variable. So a discrete random variable will take on values in such a way that you can line them up in your real number line. And they will appear like this. They are like comparable to your set of integers. They are countable, so you can count them. 1, 2, 3, 4, 5, so on and so forth. And there are no values between consecutive integers. You don't have an integer between 4 and 5. You don't have an integer between 1 and 2. So what would be an example of a random variable that is discrete? The size of a family. So the size of a family can be 2, 3, 4, 5, 6. Mom, dad, kuya, ate, and bunso. The number of books that you own, or the number of books that your school keeps in the library. There could be hundreds or thousands of them. Now, how about your grades? This is the grading system for many schools. And this is actually an example of a discrete random variable, although each outcome is actually a real number. But this is a discrete random variable because if you were to write this down on your real number line, its distribution will be like the distribution of a finite set of integers. 1, 1.25, 1.5, 1.75, 2, so on and so forth. So the outcomes are countable. They are finite and countable. Now let us compare it with a continuous random variable. Okay, so when you speak about continuous random variable, think about an interval of real numbers. Let's say, for example, the set of real numbers between 3 and 5. So what are the real numbers between 3 and 5? Well, you have 4. What else? You have 3.5. You have 4.5. Okay. So can you count this? Yes, I can count them. 3, 3.5, 4, 4.55. So you have 5 elements. But are there more elements in this interval, 3 to 5? Yes, because between 3 and 3.5, you have 3.1. Okay, you have 3.2, so on and so forth. And between 3 and 3.1, you have still another real number. You have 3.01, 3.02. So this interval of real numbers is non-countable. You cannot count the number of elements in this interval. And so that is one idea you can have in mind when you are talking about continuous random variable. So what would be an example of a random variable that is continuous? Well, the weights of newborn babies. So the possible weights can be Well, theoretically, the possible weights can be any weight between 3 kilograms to 5 kilograms. What else? Well, the quantity of water dispensed by a water dispenser, let's say for example in 1 minute. So the quantity of water can be any quantity between 8 ounces to 15 ounces. And so it is comparable to your interval of real numbers. So another thing to remember about normal probability distribution is its probability histogram is a continuous curve in the shape of a bell. The probability histogram is the graphical representation of the probability distribution, and we did this last time. This one would be an example of a probability distribution for a discrete random variable. But for a continuous random variable, you have an infinite number of possible outcomes. And so, your probability distribution transforms into a curve, into something like this. Okay, so how shall we interpret the normal probability distribution using the things that we see around us? So let's say, for example, we are interested in knowing the weights of male college students in your school. There is an average weight for all men in your school. We call it the average weight. Now, if I were to pick 100 people randomly, many of them, their weights would cluster close to the average weight. But among those 100 persons that I chose, a few of them would be overweight and possibly even obese. And then again, a few of them would be underweight and severely underweight maybe. So this is for the distribution of weights. We can say the same thing with height. Okay, so in a university, if we shall pay attention only to man, there is an average height for man, for all men in your school. Now, if I were to pick 200 or 100 men randomly, many of the people that I would pick, their heights would cluster close to the average height. But there are a few of them who would be tall and very tall, and a few of them who are going to be short. So what are some continuous random variables that are observed to follow a normal probability distribution? And by the way, not all continuous random variables follow a normal probability distribution. Some of them do. So what are these? Well, IQ tests, body temperature, quantity of water dispensed in a water dispenser, height, weight, quantity of rainfall in a day, quantity of juice contained in a can sold in groceries, and errors in measurements. So this is our first video for normal probability distribution, and we shall devote 2 more. One is for the standard normal probability distribution, and the other one would be how to compute for the probability of events that follow a normal probability distribution.